Today we're finishing up 4.3 though. Still dividing polynomials. Today we're doing what's known as synthetic division. Put the phone away and eyes up here, please. Now, synthetic division is a shortcut to dividing, because you probably noticed that when we do long division, especially on some problems, it gets to be a lot. Yes, it gets to be a lot. That's what I'm going with. It gets long. So sometimes it would be nice if there was a shorter way. Now, synthetic division does not always work. Synthetic division is a shortcut that works in a very specific situation. Thankfully, though, synthetic division is actually going to show up in one of our most common formats that we're going to see things. So a shortcut to dividing polynomials. Or specifically to dividing a polynomial by a binomial in the form what's a binomial? Yes, there is multiplying, adding, subtracting of numbers and variables, but it gets more specific than that because that's just polynomials in general. What does bi mean as a prefix? 2. A binomial is a polynomial with 2 terms. Now, in this case, the binomials we're talking about are in the form of x minus some k, where k can be a positive or a negative integer. So, that means our synthetic division works as it's that k minus x idea. It means the degree of what you're dividing by is equal to 1, and the leading coefficient of what you're dividing by is equal to 1. You cannot have a number in front of the x, you cannot have an exponent, and it must have only the one term. It's got to be, or sorry, 2 terms. It's got to be a binomial. So, if synthetic division is something that you want to be able to do, and in all honesty, if you liked long division and you don't want another method of dividing, you can stick with long division. Just understand it's going to take you more time to do the dividing. But if you are a person who having too many methods to do something messes with you, long division is the way to go because it will always work. Because synthetic division only works if this is a binomial of degree 1 with leading coefficient 1. First off, is this a binomial? Yes, it's got 2 terms. That one, that one. Is its degree 1? Yes, it's a regular x. It's not x squared. Is its leading coefficient 1? Yes, x has got a coefficient of 1. So, then we can do our synthetic division. Synthetic division, there is a couple of different setups for it. One setup in our book, I believe, prefers this way. Makes a big box that looks like this. And then it puts a bunch of numbers here and numbers over here. I personally don't prefer that way. I personally prefer a way that looks like this. It's got a little tiny box going the other direction as long division. And then a line below that, it's got bar going across. So, setup of long division. In the tiny little box goes the number k. Now keep in mind, look at what the form was. It's in the form of x minus k, which means the k is the opposite of the number in the binomial. Oops, I forgot the word the before. The fact that it's got the minus is telling us it needs that opposite. I've got minus 3 right here. Opposite of minus 3, or no, opposite of negative 3, in other words, is positive 3. That's what goes there. And then across the top here, to the right of that little mini box, you are going to have the coefficients of the polynomial in order. In other words, it's got to be in standard form. Without any of them, or without having any missing terms. Is the thing I'm dividing have any missing terms? Yes, what term is it missing? The regular x term. And if I'm missing an x term, which should go right here, what do I put? That there's an additional 0x. So I'm going to put the coefficients. Coefficients are the number in front. What's the coefficient of the x cubed? Negative 1. Then I'm going to leave a little bit of space. Coefficient of the x squared is 4. Then I would move on to the x. Coefficient is 0. Then I would move on to the constant. 9. Now, what synthetic division does, when it puts the opposite of the thing you're dividing by, it essentially takes care of the fact that in long division you're typically subtracting. It's kind of distributed that negative for you already. It also, if I were to think about long division, and I were to think about what multiplies by x to get me negative x cubed, the number in front of whatever the variable is going to be, in this case x squared, it's always just going to be the coefficient of the first term. So the first thing you do when you're doing synthetic division is you take the first coefficient and you just bring it down. Because what do I multiply by x to get negative x cubed? Negative 1. And then it's going to be x squared. But we ignore the variables when we're doing synthetic division. We bring them back later. What do you typically do after you figure out the number in long division? Off to the side, we do some multiplication. We're going to do some multiplication. The number we got, and we just have to focus on this. 3 times negative 1. Negative 3. Put that here. And the process of synthetic division goes, once you get the structure and you pull down the first term, Multiply, then add, multiply, then add, multiply, then add, multiply, then add, as many times as it takes till you get that entire bottom row. We multiplied. Now add. What is 4 plus negative 3? 1. And then we multiply again. What is 3 times 1? 3. Put that here. And then we add. 0 plus 3 is 3. And then we multiply again. What is 3 times 3? 9. And we put that here. And then we add. What is 9 plus 9? 18. When you're doing synthetic division, the last number that you get references our remainder. The rest of the numbers represent the constant and the coefficient of the variables. Now, because of the fact that what we divide by always has to be 1x to the power of 1, not only is the first number going to be the leading coefficient of what it was, the exponent always has to be exactly 1 smaller than this. Because x cubed divided by an x is going to be x squared. So, our final answer, negative 1 in front of x squared, always starts the power 1 smaller than what you were dividing by. If this is x squared, the next term is regular x's, plus 1x. If this is regular x's, the next terms are the constant, plus 3. And after that, you get the remainder, plus 18 getting divided by x minus 3. Do I need the 1's in front of the x's? No. That's synthetic division. Significantly less writing. But unlike long division, which follows through with the math that you did in elementary school and it's a lot more intuitive, this one you just kind of have to know how to do it. And on top of that, it doesn't always work. So there is the drawback of synthetic. Okay. Try another. 2x cubed minus x minus 7 getting multiplied by x plus 3, which is to the power of negative 1. Is this actually multiplying? No. Why not? A negative 1 exponent is telling you to divide things. So, I'm going to do synthetic. Wait, can I do synthetic? Yes, because why? Yes. Number in front is a 1, number up here is a 1, and this is a binomial. Okay, what goes in the little box? Negative 3, opposite of that number. What goes along here? No. Close. 2, 0, negative 1, negative 7. Because I'm missing my x squared term. Once I get the setup, first thing I do is bring this down. Always going to start it. Then the pattern goes back and forth between two operations. What, then what? Multiply, add, multiply, add, multiply, add, multiply, add. What am I multiplying? Negative 3 times 2. Negative 6. Where do I put it? next open slot on the next row, and then I add 0 plus negative 6. Negative 6. And I multiply again. This time I'm multiplying the negative 3 and the negative 6. 18, put it here. Add 17. Multiply again. Negative 3 times 17. Negative 51. Add. Negative 58. Now I know my answer is going to start with 2, but 2 what? Why x squared? Because it has to be 1 less than the original. From there, if that's squared, this is regular x, this is the constant, that's the remainder. They always just decrease by 1 as you go through. So minus 6 regular x plus 17 minus, how's the remainder work again? If I put a minus, it's just regular 58 over what you were dividing by, x plus 3. Simplify your fraction if you can. We can't. In fact, when you're doing synthetic division, none of them should be able to simplify. Yeah, for a lot of people, this is easier. Just not as intuitive. It doesn't always work. Okay, this one I'm going to have you try it on your own, and then we're going to end up shifting gears a little bit with something we can do with synthetic division. See if you could try that one on your own. Yeah, because it's negative 9 times 10 squared. Not right this second.
I think I did it right.
It's negative 9 times 5. Okay. I didn't quite get to everyone, but when I initially write it out, what goes in the little box? Negative 9. What gets listed across the top? 8, 72, 0, 5, and 44. Multiply, add, multiply, add, multiply, add. Along the bottom, you should have gotten 8, 0, 0, 5, negative 1. 8 is x to what power? X cubed. The 0 and the 0 represent the x squared and the regular x. Do you need them? No. The 5 is the constant. And then you've got minus 1 over x plus 9. Now, one other thing that we're going to do with synthetic division. It's called the remainder theorem. Oh, before we talk about the remainder theorem, there's one other thing that I wanted to mention. I don't know why I put a question mark there. The colon was right. What if I had one like that? Can I do synthetic division? No. What do you have to do instead? Long division. You would have to do what we did yesterday. What about something like that? Can you do synthetic division? No. What would you have to do? No. The individual fractions, the monomial division. So keep an eye on those things because your worksheet today will have some of those mixed in. Okay, back to where I was going. The remainder theorem. The remainder theorem states the following. If a polynomial, which we will call f of x, is divided by x minus k, then the remainder that you will get actually works as a way to evaluate, or is equal to, f of k. Now, the remainder theorem is not necessarily something that you have to use. It just kind of works as a shortcut to do some evaluating as well. Easiest way to do it is to use synthetic division to evaluate. to evaluate specifically the function at a specific value. So let's say I was given f of x is equal to 5x to the 4th plus 2x cubed minus 20x minus 6, and I want to evaluate that where x is equal to 2. Now in all technicality, when I'm evaluating that at x equals 2, I'm looking for f of 2, and I can plug 2 into all the places that x is, and it will work. But, especially if you are without a calculator at the time, or without a more scientific calculator, it can become a bit tedious. Especially if you've only got your phone calculator. Can you type that entire polynomial into your phone calculator? No. Scientific calculator, it's not bad. But a shortcut that you can do is using that synthetic division. So, I set up my synthetic division. Now note that the remainder theorem says it will tell you what f of k is when you're dividing by x minus k. Which means when we typically put the opposite number in this box, it's already given me what that opposite number is. That little box, you just put whatever the number is that you have. And then we line up our numbers. We got 5, we've got 2, we're missing the squared term, so we put a 0, because I have 0x squareds going on. And then we got negative 20 and negative 6. We pull down the first term, I get 5. And then I do all of the normal things. 2 times 5 is 10. And I add 2 plus 10 is 12. And I multiply and I add, and I multiply and I add, and I multiply and I add. 2 times 12? 24. 24 plus 0? 24. 2 times 24? 48. Negative 20 plus 48? 28. 2 times 28? 56. Negative 6 plus 56? 50. Which means f of 2 is equal to 50. Could I have plugged 2 in? Absolutely. I could have done that. And then I'd be asking myself, what is 2 to the 4th? If you know that, that gives you a good start at 16, but then all of a sudden you have to do 16 times 5. Is 16 times 5 a slightly bigger calculation than what we did on any of these? That's the advantage of this theorem, is that it gives you smaller numbers to work with. Is it a required thing to be able to do? No. If you know the function and you know of x value, you can always plug it in to find the function's output. But it's a nice little shortcut sometimes. Works out nice sometimes. Especially as the numbers get larger that you're dividing by. But, yeah. That's that. I'm not going to do a second example of that.